Hi, this is APBio Chapter 43, and I hope you're not playing Snake. Say hi. Hi. All right, so we are on behavioral ecology, which is so ironic right now. Behavior. Okay, so here's the first big ticket item you need to get straight in your head. Okay, so it's the nature versus nurture argument, which is, does our behavior come from our genes? So it's like inevitable, right? If it's in your DNA. It doesn't mean you have to, if there was some gene for being a mass murderer, it doesn't mean you have to be that, right? You could hopefully change your behavior in some way. If you can change or modulate it in some way, it's not a fixed action pattern. A fixed action pattern would be like a weaver bird will weave a nest, and when they do that, they look for an upside down Y stick. And then once they find that, they start thatching, and they make it in a circle. And once they finish kind of this sphere, they have an opening at the bottom, and they make a tunnel out of it. And if scientists meanly have gone through and they've undone the thatching by the time they're working on the tunnel, when they undo the thatching up at the top, even though the weaver bird made the whole thing, he doesn't know how to fix it. He just is like looking, how come none of the ladies want to come into my nest? And he can't go back and fix it because he has to start from the very beginning. He doesn't know how to go back and correct mid-step. So that would be something that's innate. That's in your genes. It's unchangeable. Then there's behavior that can just mature. If you remember, we looked at the goslings, and we looked at not the rolling. Remember, that would be a fixed action pattern. That's innate. But when they would learn to peck, they might get better, but it could be not because so much they're learning, but their motor control is improving, and so they can peck on the target more readily. Learning we talked about associative behavior in learning, things like habituation, like what to be afraid of, what not to be afraid of. Learning how to prepare the food that you're going to eat, like we looked at the monkeys that wash the sweet potatoes. Those are all examples of learning, associative learning. So that's the big ticket on this, is the information. Is the information in your genes? Is it genetic? Or is it something that can change over time? We looked at a couple key experiments. I would be comfortable with those, like on a final or a test. I would say, name 2 experiments that provide evidence for genetic behavior. Name 2 experiments that show the environment determines your behavior. So be comfortable with both of those. Remember, we talked about the lovebird and the size of the nesting material, and that they made the hybrids who made the hybrid length. We also looked at the snake experiments that had to do with the number of tongue flicks, and that was just because of how many tongue flicks they had, whether or not they could taste the slugs. And we did a lot, talked about twin studies. We talked about aplysia and how they have a really ornate behavior before they lay eggs, and even though they hadn't copulated, hadn't had sex, if they were given the egg-laying hormone, then they went through all the steps for egg-laying behavior. And remember too, the FOSB gene with mice, that mothering gene. And if that mothering gene was turned off, then they didn't know how to care for their young, like keeping them warm or if they walked away. Okay, so then we moved on to, we addressed the idea of fixed action patterns. Does not improve with learning. How the goose will continue to roll something once they've started that behavior, even if you remove the false egg out of the way or even a real egg out of the way, they'll continue on their rolling behavior. Bird dances, mating dances can be fixed action patterns. Where we see learning, like we talked about habituation, the key one you're going to want to know there is imprinting. And that is, generally speaking, it is a particular time when something can be learned, like a bird's song. And when we looked at olfactory imprinting, I don't know if I gave this example in all the classes. Did I talk about salmon and finding their home stream? And they swim their way back to they smell their way back to their home stream. That's an example of imprinting. We looked at the conclusions with birds, and with birds we found that an adult tutor always helped and assisted, and they could learn a song probably at any age, as long as they had a tutor. Were you able to fix and submit what you needed to submit?
Yeah.
Okay, good job, guys. And then we talked about associative learning, and on that one, you're putting two different elements. You're putting them together, one with the other, and we looked at classical conditioning. And just because classical conditioning has a dog, don't assume every time there's a dog that you're talking about classical conditioning, right? Because most dog training is what kind of conditioning? Operant conditioning. I remember that because I'm like, perform that operation and then you get a treat. So on classical conditioning, you're taking an unconditioned stimulus. Originally, it's unconditioned, like a bell wouldn't trigger anything, but you get it to trigger that physiological response of salivating. They become afraid of it. You could do that with a dog if, normally if you showed a dog a newspaper, it wouldn't make them cower and fear in a corner. But if every time you picked up a newspaper, you beat the dog, I'm not saying to do that, that would be a bad thing, but that would be an example of classical conditioning where they feared that newspaper every time they saw it because they knew something bad was going to happen. That's not a normal response, but they would associate it together. So that would be classical conditioning. Operant conditioning, like we talked about, this is where you perform some task and you either get a reward or a punishment. You're going to get an electric shock or you're going to get some reward with food. We also talked about orientation and navigation in birds. I mean, that's huge. They're flying, hundreds and thousands of miles sometimes in order to do their migration pattern. Are they able to tell where they are, correct their condition? And we found that it had a lot to do with what in helping them? Yeah, the magnetic poles. And so they, messed with their magnetic, arrangement on their head, and then they could not navigate. We also looked at observation imitation as a form of learning, and we looked at insight learning, having that aha moment. The only real one I provided you with was the crow figuring out a way to access the food by pulling up the string. Okay, next we talked about, this chapter's pretty easy, isn't it? Yeah. Next we talked about communication. And the thing here about communication is the more of them that you do in conjunction, the more likely it is that it's going to be specific to your species, that nobody else can copy it. So you might have a visual communication along with sound. And the combination of those two is going to be the releaser that triggers the behavior in that same species that you're trying to communicate with. Because remember, in communication, you're trying to alter the behavior of someone else, right? And if that's behavior that can be learned, right? Just like you learned, your parents taught you, come over here, right? So you learned what that word meant and that you were to walk towards your parents. So those were signals they were influencing your behavior. So that would be underneath the umbrella of learned behavior, if what I communicate to you. Now, exceptions to the rule, right, is if it's a straight up, if I'm communicating with you and it's just a straight up releaser like the red underbelly of a stickleback and you can't help but behave that way. Remember we talked about, I don't know if I talked about it in all the classes, where the one bird, it's kind of horrid, but the males sit on the nest, and as long as those eggs were there, then she paid no attention to her. But if she destroyed the eggs, so he had nobody to protect, and then presented herself, then he would mate with her. That is a form of that is something that's triggering a behavior, but communication takes it up a higher level than that. It's more than just simple reproductive actions. Okay, so we talked about some of the ways you can communicate is chemical, spray, smell. Mated butterflies smell differently than virgin butterflies, so that males don't waste their time on them. We talked about auditory communication, and I gave you that example of that girl, and she can mimic all those sounds, if you remember, and humans are really good at that. And visual also is here. And then tactile. On tactile, you want to make sure that you remember the cool one on that, the classic experiment for tactile is the bee dance. And remember, they can communicate two things by dancing. Remember, you're not watching the dancer. What are you doing? You're feeling the dancer. And so remember, if you waggle straight up the hive, that means when you go outside, Mr. Bee, fly right towards the sun. If you're doing your waggles down the hive, that would mean when you go out of the hive, fly what? Away from the sun. Then how far you fly, that's communicated by the number of waggles, and that's species specific. Okay? And that is tactile communication. Then we went into, we went into behavioral ecology and how natural selection can influence our behavior and what traits are selected for. Meaning if you exhibit this behavior, then you're more likely to survive and reproduce. One of those would be foraging behavior. So it's knowing where to hunt and what to hunt, and how to get your food, whether it's live prey or plant material, whatever. So that would be foraging behavior. We talked about, and this part was a little bit of a review, territoriality, marking. That's another form of behavior that is selected for where it is advantageous. And we looked at the different types of sexual selection. And this also was a review as well. So intrasexual selection is anything that facilitates competition between the same species. So oftentimes it's males. It could be a brutal battle, or it could just be a little dance that they do, and they have a little dance-off to determine who's the one that's most fit to reproduce their genes. Intersexual selection usually has to do with female choice. Do you remember the two hypotheses we had about female choice? Good gene and which one is good looking? There we go. All right. And then remember sexual dimorphism as well? Do you remember what that means?
They look different.
They look different. The males and females look different. Okay, and we looked at all different examples of that in a previous unit, and battles, and dominance hierarchies. And then last but not least, we talked about, okay, the process of living together. If you're going to live together socially, okay, there must be that the benefits outweigh the cost. So if we look in this situation, there's only one female reproducing here, and that is the queen. So everybody else is abdicating their rights to reproduce, which goes against the idea, right, of natural selection, because natural selection would say the best fit, and we say if you're fit, you are what? Passing on your genes. So how would it be to ever be a benefit then to live with others? What could we say? Why are they willing to let the queen? Yeah.
Because they're all related to the queen, and so their genes are in the queen.
Exactly. So they're highly related, and that's why they would allow it. That's why chimps might not fight with other chimps to have sex with a female, because they're all kind of related. So it's good for the team, that you're gonna get those genes passed on. Also, just the dynamics of living together. You have more eyes that can work and look for predators. You can, give the different job responsibilities, like the teenagers are babysitting and other ones are standing guard. And speaking of standing guard up on the hill, why would that ever be selected for? When we talk about behavioral ecology, we're talking about why would that be selected for, to stand guard? Because whoever stands guard is more likely going to be the one that's killed. And if he's killed, how does that gene ever get passed on?
He might be protecting his kids because they.
Okay. Are you telling me he's related to the ones that he's protecting?
Yeah.
Yes, and those could be his offspring. So it's to his benefit if he's maybe past the age of reproduction, or maybe he's still reproducing. He does in fact have some genes down there that will get passed on. Otherwise, you would start to eliminate all the altruistic ones, the ones that are self-sacrificial. And what we found out is they're not really self-sacrificial at all, right? They're really looking out for the best interest. There's direct selection where you're looking out for yourself and directly for your offspring. But if you're related to others too, that would be called what kind of selection? Starts with a K. Kin selection. Yeah. So there's probably no real altruism out there because it would be selected against. Then there's the idea of I'll scratch your back if... Right. And the one that we looked at for that one would be like the vampire bats. We went through all of that. And with the vampire bats, then they know that if they live in a group, that if they don't get a blood meal, they can lick their neighbor, and by licking their neighbor will regurgitate food to them, and then at that point they can repay that favor at a future time. Okay. I don't know if we got to all the questions. Do you want to do some of the questions in here? Yes. Okay. You missed my Let's go in as your favorite abiotic factor. I'm going to pause you just for a minute. Okay, here we go. This one might be just too. Oh, good job! Well done. Well done. Okay, let's try some more. Here we go. I'm going to pause you because you can't see the question anyway. Okay, here we go. Here we go. Yay! 100% there. Yay, 100%. Oh.
What's inclusive?
Inclusive fitness would be like kin selection.
Oh.
Yeah.
So you're sacrificing for yourself.
Yeah, this one is saying benefits other and has the potential to decrease lifetime reproductive success of the member exhibiting. That is defined as altruism, is you being limited. Did we say it even actually exists? Probably not. Probably there is no altruistic behavior. Okay. Yeah, communication. What did they say? Imprinting. No, a signal by a sender that may influence the behavior of a receiver. Imprinting is different. That is when you learn a behavior at a certain time, right? So that you're receptive to it. So that would not be the right answer there. Okay, let's see what else we have here. Here we go. Pause you real quick.
What is
that?
I mean, I know what it means, but I don't know what it means.
Yay! They have forms that would be helpful if you had them filled out before you took the test. So I don't know that week. That's time.
That same week is
You don't have to take the test? Okay, I'm going to pause you again. Yay! Good job.
your breath smells worse.
Golly, you have bigger problems at that point.
I think that's it. The first question was behavior. Okay, guys, good job. Were there any other questions that you had or wanted to ask me?
We love you.
I love you.
Yes. And a good evening. Make some cookies.
Yeah. Oh. Okay. Have a good evening and have a piece of toast. Don't stay up too late. Love you.